Someone shaped this by hand. A barbed point, carved from the antler of a red deer, worked along one edge into a row of teeth. It came up in a fishing net 25 miles off the coast of Norfolk, sealed inside a block of peat. Peat does not form on a seabed, it forms on land. And the ground where this peat formed now lies beneath 35 meters of the North Sea. The net belonged to the steam drifter Kalinda, fishing between the Lehman and Ower banks in September 1931. The crew broke the block open and found the point inside. It had been made by a human being, and it had come from a place where no human being can live now. Its age puts people here when this part of the North Sea basin was dry, open terrain. Britain was not an island. It was joined to continental Europe across an immense landscape of rivers, marshes, woods, and open ground. It is now called Doggerland. The name comes from the Dogger Bank offshore, which took its own name from the Dogger, a Dutch fishing boat, a country named after a vessel that sailed over its roof. The name also invites exaggeration. Doggerland is usually sold as a lost world erased by a single prehistoric tsunami. The real discovery is stranger, because it needed no city, no written record, and almost no excavation. Archaeologists rebuilt a vanished territory out of objects torn from their context, sound waves collected for the oil industry, pollen sealed in mud, and fragments of DNA beneath the seabed. That same evidence dismantled the cleanest version of the disaster. Doggerland did not exist one morning and vanish that afternoon. Its destruction ran across generations, and the famous tsunami may not have delivered the final blow. So the challenge was never simply to find evidence, it was to work out what each archive could represent and what it could not. How do you reconstruct an inhabited landscape you cannot excavate? And why did it disappear in stages, rather than in one catastrophe? The Kalinda Point proved that people had occupied land now beneath the North Sea. It did not reveal where they had lived. Direct radiocarbon dating later placed it at roughly 12,000 years before the Common Era, moving it out of its original Mesolithic classification and into the Upper Paleolithic. But dating an object does not restore the scene around it. The peat recovered in 1931 was not kept, and the exact position it came from was never recorded. The artifact had a date. Its archaeological relationships were gone. A trawler can drag an artifact away from where it lay. A dredger can mix material from different layers. An isolated point will tell you its material, its manufacture, and its age, but not whether it rested beside a hearth, a camp, or a kill site. Archaeology depends on the relationships between objects. The sea had broken those relationships apart, yet every object recovered only deepened the problem. Worked flint, antler tools, animal bones, and ancient peat established a long record of dry land beneath the sea. Presence was proven. Context was destroyed. The landscape itself stayed invisible, until an industry looking for something else entirely supplied the first map. Then the mystery changed scale. Doggerland was not a narrow causeway. Seismic surveys have since mapped more than 40,000 square kilometers of it, an area about the size of Denmark, and that is only the surveyed part. At different times, exposed terrain stretched between eastern Britain, the Low Countries, northern Germany, and Denmark. During the last glacial maximum, global sea level stood about 120 meters below its modern position because enormous volumes of water were locked into the ice sheets. The familiar coastline of northwestern Europe simply did not exist. Calling this a land bridge makes it sound like empty space between important places. It was itself a place, a shifting mosaic of basins, wetlands, lakes, ridges, and coastlines, where fresh water, migrating animals, fish, and seasonal plants could make parts of it extremely attractive. But there was still no reliable map. The modern seabed is not the old ground surface. Thousands of years of erosion, deposition, and marine activity have rewritten it. The landscape archaeologists wanted was buried underneath the landscape they could see. The first true map of Doggerland would not come from an archaeological trench. It would come from seismic data gathered in the search for oil and gas. Marine seismic surveys record echoes returned from geological boundaries beneath the seabed. Energy companies use them to investigate deep formations. Archaeologists realize the same records preserve something much shallower. channels, basins, and sediment layers left behind by a vanished landscape. When researchers processed the data, an ancient geography emerged. They traced river systems beneath the southern North Sea, along with former lakes, estuaries, valleys, hills, and coastlines. Features invisible at the surface could be followed across huge areas in 3 dimensions. With that map, sampling no longer had to be blind. And that mattered because human activity is never distributed at random. A source of fresh water, a river junction, a rise above a wetland, these concentrate movement and repeated occupation. Once located, they showed researchers where evidence of human presence was most likely to survive. But the seismic record was not a photograph. Reflections require interpretation. A buried channel does not tell you when water ran through it, whether that water was fresh or tidal, or whether anyone ever stood on its bank. A river was visible. A campsite beside it was not. So researchers needed physical samples from the mapped layers. Marine cores provided narrow columns of sediment that could preserve wetland peat, river sand, material for radiocarbon dating, microscopic indicators of salinity, and pollen released by vegetation long dead. The 2 methods do different halves of the same job. Seismic data establishes the buried architecture. Cores establish what occupied it and when it changed. A channel's sediments reveal whether it belonged to a freshwater river, an estuary, or the open sea. The result is not one stable map of Doggerland. It is a sequence of landscapes. A river valley becomes a marsh becomes a lagoon, a ridge becomes a peninsula, then an island. Each transformation changes what can be eaten, drunk, and traveled, which is why any image claiming to show the outline of Doggerland is misleading unless it carries a date. There was never one Doggerland. There were many. Pollen and animal remains had already delivered partial reconstructions of Doggerland's environment. Then a study published this year in the Proceedings of the National Academy of Sciences added a completely different archive: ancient sedimentary DNA. Organisms shed genetic material into their surroundings, and fragments of it survive in sediment long after every visible trace has gone. Researchers analyzed more than 250 sediment samples from 41 marine cores along one buried river system in southern Doggerland. The aim was not to find a population, it was to rebuild a living environment. What came back was a landscape far more complex than the old image of endless late glacial tundra. Secure signals pointed to temperate vegetation surviving in southern Doggerland more than 16,000 years ago, with trees and shrubs associated with woodland. The animal evidence included boar, deer, bears, and aurochs. Some may have held on in northern refuges through the cold, rather than returning only once the climate warmed. That does not prove people occupied every sampled stretch of that river. It shows something more useful. Parts of southern Doggerland held the water, the plants, and the prey that could sustain them. This was not ground people merely crossed on the way to Britain. It was ground worth staying on. The method has hard limits. A core samples one position, not a country. 41 cores follow one river system, not the whole North Sea plain. DNA can be reworked along with the sediment holding it, and no human DNA was recovered. But that is the achievement. A landscape first outlined by reflected sound could now be filled with living things, rebuilt from microscopic fragments. The sea had preserved different parts of that world in different archives. Those archives also kill a misconception. Doggerland was real, but the word country here is geographical, not political. There was no unified people, no state, no cities, no monuments. This was a territory the size of Denmark, occupied at different times by mobile hunter-gatherers, and that is what makes its loss so hard to see. When a city drowns, it leaves a city. When this drowned, it left a changed coastline. Because if these communities depended on rivers, wetlands, and seasonal routes, then losing Doggerland was never the demolition of buildings. It was the slow fragmentation of everything that supplied water, food, and passage. As the last ice sheets retreated, water returned to the ocean, sea level rose, and the land itself was still reacting to the removal of the ice, lifting in some places, sinking in others. Across a landscape as flat as Doggerland, a small vertical change produced an enormous horizontal one. A rise of a single meter could push a coastline kilometers inland. Inundation models show what that did. The process did not politely move a clean shoreline. It reorganized drainage, drove tidal influence deep into the interior, and cut connected terrain into pieces. Freshwater environments turned brackish. Wetlands spread. Familiar routes were interrupted. High ground became isolated, then surrounded. Consider what that meant at the scale of a single life. Nobody watched a country sink. What people would actually have registered was smaller and stranger. A river mouth that had always been fresh, turning salt. A crossing that worked in your father's time, now needing a boat. A marsh widening by the width of a field each season, and then not stopping. There are no names for any of this. No speeches, no written memory. But mobility was already built into hunter-gatherer life, and the real question was never whether a population stood still and waited for the sea. It is how shrinking access and shifting resources rewrote where people could go. Some episodes of flooding could be locally fast. Across the region as a whole, the transformation ran for many generations. A freshwater location could later face tidal flooding. A route open to one generation could be impractical for the next. Eventually, the geography linking Britain to continental Europe broke down into narrowing corridors and islands. That slow progression is why saying Doggerland sank is such a poor description. Rising water drowned most of it, while erosion and sediment reworked whatever evidence was left. Groups could have moved toward what is now Britain or toward the continent, but direct routes are hard to prove. By the early Holocene, Doggerland had already been radically reduced. And then around 8,150 years ago, a vast submarine landslide let go off the coast of Norway. The Storegga slide displaced roughly 3,000 cubic kilometers of sediment, enough to bury the whole of Denmark under 70 meters of debris. It generated a tsunami that crossed the North Atlantic and the North Sea. It is the perfect ending for a modern documentary. One enormous wave, one lost land, one final day. But it is precisely at this point that the evidence refuses to cooperate. Deposits left by the Storegga tsunami have been identified around Norway, around Scotland, and along other North Sea coasts. Offshore cores have found tsunami-like deposits in the southern North Sea as well. The event was real, and across exposed low-lying ground, its effects could have been devastating. Water funneled into estuaries and valleys would have reached any communities there with almost no warning. Earlier interpretations linked Storegga directly to the final destruction of Doggerland, and it was a good proposal. The wave arrived when the remaining terrain was already fragmented. A single catastrophic surge could overwhelm coastal communities and poison fresh water and food. Then the impact was mapped, and it turned out to be wildly uneven. The height and reach of a tsunami depend on seabed depth, coastal shape, approach direction, and local topography. A valley can funnel water into one area, while high ground, a few kilometers away, shields another completely. In part of southern Doggerland, the evidence shows floodwater withdrawing and the land recovering afterwards. This does not make the tsunami a footnote. It changes its position in the causal chain. Storegga was an acute shock delivered to a landscape already being dismantled, slowly by rising sea level. It very likely destroyed settlements, killed people, and pushed abandonment forward in specific places. What it did not do was convert an intact country into open sea in an afternoon. Different parts of Doggerland went under at different times, and some ground survived well beyond the wave. There was no single last day for the whole landscape, and archaeology cannot hand us the fate of a final community. No excavated settlement records a last meal. What the evidence can do is show where terrain stayed accessible, where flooding was sudden, and where material may still be lying, protected under the seabed. And that last category has become urgent. The same sea that hid Doggerland is now being surveyed and built on at a scale it has never seen. Once again, an industry chasing a modern objective is generating evidence of the prehistoric landscape underneath it. Offshore wind development requires seabed surveys, foundation work, and cable routes. Construction can destroy buried deposits, but the same projects produce high-resolution data archaeology could never have afforded on its own. Magnetometry, seismic imaging, targeted coring, Underwater robotics and environmental DNA can now pick out areas where intact land surfaces may still remain. Projects including Subnautica are building methods to investigate submerged landscapes across the North and Baltic Seas, while decisions about offshore infrastructure are still being made. The objective is no longer to draw another broad map. It is to move toward the specific traces of human activity and to secure their context before it is gone. The Kalinda Point began as an object without an address. Seismic data gave the landscape its shape. Cores supplied environments at specific points. Ancient DNA recovered the living world along one river system. Inundation models explained how usable ground contracted. Each method made the lost landscape more precise, and not one of them made it complete. That is the real answer. Doggerland was not recovered through one decisive discovery. It was recovered by joining together archives that were each incomplete in a different way. An antler point in a block of peat, a buried channel detected by sound, pollen under a microscope, DNA in marine mud. Individually, almost nothing. Together, they describe an inhabited country between Britain and Europe, and a disappearance whose evidence is still down there, under the North Sea, waiting. And Doggerland is not the only country the water took. It is only the one we have learned how to look for.